There are things other than carbons that may branch off the main carbon chain. Hi, my name is Tanvir, and today let me introduce you to alkyl halides. Alkyl refers to carbon chain and halide refers to halogen, so an alkyl halide is a halogen branching off the carbon chain. Do you remember what a halogen is? Yes, it's the elements in the seventh or second last group of the periodic table. Can you name the first four? Yes, there are bromine, fluorine, chlorine, and iodine. Alkyl halides are usually represented by Rx, where R is the hydrocarbon and X is the halogen. The general formula of an alkyl halide is this, where X represents the halogen. Now, we know what a line diagram for an alkane looks like. Please draw that down, and you may take a moment to pause the video. Now, try drawing what you think the line diagram for an alkyl halide is. Again, you may pause the video.
It looks something like this, and if you got it incorrect, please draw down the correct one.
Now, let's talk about naming alkyl halides. You may use IUPAC rules or the common rules for naming these alkyl halides. Let's talk about naming with common names first. All you have to do is name the alkyl group, name the halogen, and end in IDE.
For example, this would be ethyl bromide and the second one would be isopropyl chloride. Common names that you should probably remember are methylene chloride, chloroform, and carbon tetrachloride. Similar compounds exist for most other halogens, for example, bromoform.
Now let's talk about naming using the IUPAC rules. But before we start that, let's just discuss what iodine, bromine, chlorine, and fluorine sound like in the name.
Let's use this line diagram as an example. So like always, you have to number the longest parent chain. If the halogen is the highest priority branch, it gets lowest number. In this case, it does. So since this is a 6-carbon chain, we are going to get a first name of hex, and only single bonds gives us a last name of ane. Since iodine is on carbon 2, it gives us 2-iodo, and the methyl group on carbon 5 gives us 5-methyl. This gives us the name of 2-iodo 5-methylhexane. Iodo is before methyl because I comes before M in the alphabet, and we used alphabetical order for prefixes. Let's do another example. Here we have two line diagrams. When you have both carbon and halogen groups, you want to number so that you have the lowest number in total. So let's start numbering from the left in both cases. Both pair chains have a total of 5 carbons and all single bonds, so we will use pent and ane. The first one has a bromine on carbon 2 and methyl on carbon 3, giving us 2-bromo 3-methyl, and the second one has a bromine on carbon 3 and a methyl on carbon 2, giving us 3-bromo 2-methyl. Keeping in mind alphabetical order for prefixes, we get the names of 2-bromo 3-methylpentane and 3-bromo 2-methylpentane. Let's look at another one. We have a parent chain of 6 carbons for a first name of hex, only single bonds gives us the last name of ane, and a ring gives us a prefix of cycle. For numbering, we will start from the carbon that has more substituents coming off it, giving the 2 chlorines the number of 1 and iodine the next lowest number. 2 chlorines on carbon 1 gives us 1,1-dichloro, and di represents 2, and between the ones we are going to have a comma. And iodide on carbon 3 gives us 3-iodo. So we have a final name of 1,1-dichloro-3-iodocyclohexane, and we do not consider di when thinking of alphabetical order. Now let's do one final example. So our longest parent chain is 5 carbons, giving us the first name of pent. We have a double bond, giving us a last name of ene, and since the double bond is on carbon 1, we're going to have 1 ene. And when numbering, the double bond has the priority, so it gets the lowest number. And we have a bromine on carbon 5, giving us 5-bromo, for a final name of 5-bromo pent 1-ene.
Now let's talk about drawing alkyl halides. First, let's talk about drawing the line diagrams. It's actually pretty simple once you understand the names.
Let's use 2-bromo 3-methylheptane as an example. First, we want to look at which the longest carbon chain is. Since it is hep, that means we have a 7-carbon chain. Also, since it's ane, we know it's single bonds. Now let's look at the prefixes. We have 2-bromo, so that is a bromine on carbon 2. We can choose to start numbering from either side. We also have 3-methyl, so that is a methyl group on carbon 3, and this is our final diagram. Now let's try 5-ethyl 3,3-diodo 1-ene. So we have oct, which means 8-carbon chain, ene means double bond, and 1 indicates it's on carbon 1. 5-ethyl indicates ethyl group of 5, and 3,3-diodo means 2 iodines on carbon 3. Now let's look at structural diagram. Let's draw 3-ethyl 4-fluoro 2-methyl nonane. So we have a 9-carbon parent chain giving us 9 carbons, and we're going to draw C and dashes. And then we have the ethyl group on carbon 3. And we have a fluorine group on carbon 4 and methyl group on carbon 2. Now, you can choose to add hydrogens around them or beside them. Just make sure you're adding the correct number of hydrogens depending on the bond.
Let's talk about the reactions of alkyl halides. So the first reaction we have is the substitution of alkanes to make alkyl halides. This reaction requires UV light because the UV light breaks down the Br2 or the Cl2 into a free atom. This free atom then initiates the reaction. The UV light is necessary to break the halogen into a free atom because otherwise the reaction will not happen.
For example, if we have propane plus chlorine and UV light applied to it, the hydrogen is going to be replaced by another atom, so in this case the halogen or the chlorine, and basically the chlorine is going to replace any of the hydrogens. It doesn't really matter. So as you can see, the lines that I have made are for the different hydrogens, and the chlorine is going to go any of those. Now let's look at the elimination of alkenes. Basically, you're going to make an alkene from alkyl halide. So let's look at the example of 2-bromo, 3-methyl butane, and KOH. So basically, we will remove the halogen and add a double bond. Basically, the double bond can have 2 options because from where the halogen was, it can typically bond 2 ways.
Zaitsev's rule to see which product is major and which one is minor. Zaitsev's rule states that when forming alkenes from alcohols or alkyl halides, the major product is the alkene, so the double bond, with the most carbons bonded to it, so it has the least hydrogens bonded to it.
So in this case, our first product has 4 carbon bonds, while the second product has 5 carbon bonds, making it the major product. There is one more type of reaction for alkyl halides. It is called substitution of an alkyl halide, and you can replace a hydrogen with an OH or an NH2, so you turn it into an alcohol or an amine. For example, if we have 2-bromopropane plus water, the H2O will replace the bromine with an OH, so we will have 2-propanol. Now, if we have 2-bromopropane plus NH3, the bromine will react with NH3, leaving an NH2, so we will have 2-aminopropane.
Let's quickly talk about the practical uses of alkyl halides. Alkyl halides are used in medicine. Many alkyl halides are actually used in anesthetics. They are used to cause a reversible loss of consciousness. Alkyl halides are also used in the antibiotic clindamycin. This is used for the treatment of many bacterial infections. Alkyl halides are also used in a few other medicines. Alkyl halides are also used in sucralose, which is one of the most common artificial sweeteners or sugar substitutes. The majority of ingested sucralose is not metabolized by the body, which makes it safe and also non-caloric. This particularly emphasizes the metabolic stability of the alkyl halide. Alkyl halides are also used in many different natural products, refrigerants, propellants of aerosols, and as solvents for dry cleaning and for general greasing purposes. So that's it for today's video. I hope you guys got to learn some new things and you got to understand what exactly an alkyl halide is, how it's drawn, how it's named, and what type of reactions it goes through. Well, anyways, I'll see you guys in the next video. Bye!